Hello everyone, this is our next video lecture regarding class 12. Chapter is Surface Chemistry. In this lecture, we will discuss the stability of colloids, electrophoresis, coagulation, Hardy's rule, flocculation value, coagulation power, the methods of coagulation, what are the protection of colloid and what is your gold number. So, our first topic is stability of colloidal solution. What is the stability of colloidal solution? Firstly, what is stability? Stability means to get a stable which do not carry any charge, neither a positive nor a negative charge. So, to stable the colloidal particles, what we have to do, as we know that colloidal particles contain some charges, because of that charges they repel with each other and do not settle down. So, in a given colloidal solution, the colloidal particle carry same charge which can be positive, which can be negative. So, to which prevent them to come closer and form a large particle, which I said that they do not come closer, they repel each other and do not settle down. So stability is your charged particles get stable, neutralize. So this prevents the coagulation of a colloidal particle and provide the stability to the colloidal solution. So if the colloidal particles get neutralized, then they do not get stable one, they get neutralized, they settle down. But colloidal particles carry charge on them, either positive or negative, which is responsible for the stability of a colloidal solution, colloidal particles, so that they do not come together and form a suspension. They remain in their colloidal state. So this is the demonstration of a colloidal particle in a solution. This is a beaker containing a positive colloidal solution. So positive charge separated in a beaker. When particles of a colloid come closer, they repel each other, and this is the reason that they do not get combined in a large molecule. Similarly, for a negative charge particle solution, the negative particles are placed as such, so they do not get come closer. They repel each other and remain suspended in a solution. This is the reason, this positive charge or negative charge is the reason that colloidal particles are stable. And this is the demonstration, and this is the example of negatively charged colloidal particle and positively charged colloidal particle. In negatively charged colloidal particles, the solutions, colloidal solutions of metal like silver, gold, copper, platinum will come. And in positively charged colloidal particles, iron hydroxide, aluminum hydroxide, chromium hydroxide will come. Again, further in negatively charged, we will cover starch, gelatin, and clay particles. And in positive, you can take hemoglobin and even the dyes at methylene blue and Persian blue. So, these are the types of a positively charged colloidal particles and negatively charged colloidal particles. Moving to next topic, that is electrophoresis. So, it is basically a technique which is used to check the charge which is present on a given colloidal particles which is not known to us. So to check the which charge is present on an unknown colloidal solution, we use this technique. So check the colloidal charge on a particles, we use this technique electrophoresis. So electrophoresis is a separation technique that is based on the mobility of ions in an electric field. So in this technique, we will discuss the mobility of ions. Ions have different migration rates depending upon their total charge, size, shape, and therefore they can be separated. This technique is particularly used for the macromolecules such as proteins. What we have here, we have a U-shaped tube which is attached with the funnel with the reservoir where we put colloidal solution, and in this U-shaped tube we have a water level, and by using this top cork we put the colloidal solution in this U-shaped tube, and further it get mixed with the water which will act here as a dispersion medium, and colloidal solution will be dispersed phase. So in initial without the electric effect, here the level is equal. So what we will see, we see that before electrophoresis the level is equal. The colloidal solutions in which the particles or the charged particle are present equally distributed on both sides, the level is equal. Here is your positive rod and here is your negative electrode, and after the current passes we get electrophoresis, and after electrophoresis what we will see, we see that here positive electrode, here the positive electrode, the negative charged particles which are suspended in a colloidal solution in dispersion medium, that is water, get migrated towards the positive electrode, and here the level decreases and here the level will increases. Similar thing will happen when we have a colloidal solution carrying a positive charge, but at that time the colloidal particle will migrate towards the negative electrode. So this is what happens in electrophoresis, and that is why this technique is known as a migration of ions. Moving to next, that is coagulation. It is also known as a flocculation or coagulation of a colloidal solution is basically a precipitation. The phenomena of the precipitation of a colloidal solution by addition of excess of an electrolyte is called coagulation or flocculation. This is what we have a lyophobic solution, colloidal solution, where we add electrolyte, and this electrolyte, while combined with the particles of a colloidal solution which is lyophobic, form this type of a molecules and they get coagulated, and this is the coagulation. So the phenomena of precipitation of a colloidal solution by the addition of the excess of an electrolyte is called coagulation or flocculation. So this is the precipitation. What we do, there are impurities, we add coagulant which is your electrolyte, and they get precipitate and trap the impurities, and the impurities that trapped in the coagulant settle down and form the coagulation or flocculation. So the basic of coagulation or flocculation process is simply your coagulant or electrolyte which trap the impurities and get settled down at the bottom, and you can replace it and you have a clear dispersion medium by the removal of impurities. Next is your Hardy's rule. Hardy-Schulze rule. In this rule, the flocculation is controlled by the valency of counter ion which are added in the form of a coagulant or electrolyte with the opposite charge of the colloidal particles. Few of 3 positive ions, then the 2 positive, then 1 positive ions are needed to cancel out the colloidal charge on the negative colloidal particles. More impact is the counter ion cloud. The critical coagulation power is lower for plus 3 than plus 1. So for positive one, coagulation is higher, then it goes on decreasing, and this region decreases as the charge increases. Further, we can say that according to this rule states that greater is the valency of oppositely charged ion of the electrolyte being added, which we add to neutralize or to do coagulation in a colloidal solution. So greater is the valency, faster is the coagulation. So coagulation will be faster in aluminum 3 positive than sodium positive. So the principle is electrostatic force of attraction, according to which the particles attract positive negative charges. More is the charge, or greater is the valency of the charge on an electrolyte, greater is the valency of flocculation value, and greater will be the coagulation value. Similarly for the negative particles of an electrolyte. So this is what happens. This is the positive colloidal particle which trapped by the negative electrolyte particles, and this is what we have seen. This is a -1 charge carrying electrolyte. This is your -3 charge. So this is what happens, that they trap. In -1 we need more number of electrolyte particles to neutralize this colloidal particle, but in electrolyte having a -3 charge, the electrolyte ion addition required in a lesser number because they will neutralize 3 positive charge at a time. So moving to next, flocculation value. The minimum concentration of electrolyte which is required to cause the coagulation or flocculation of a solution is known as a flocculation value. So the minimum amount of a electrolyte which is required for a coagulation or a precipitation is known as a flocculation value. The number of millimoles of an electrolyte required to bring about coagulation of 1 liter of a colloidal is basically your flocculation value. For a 1 liter, how many millimoles of electrolyte is required will justify the flocculation. Therefore, the number of millimoles of an electrolyte required for 1 liter of a solution will tell you about the flocculation value. This is what we have a stable colloidal solution. They get destabilized with time after addition of electrolyte, then the flocculation will take place. If we add lesser number of electrolyte, then the flocculation or coagulation will not take place completely. So for that we have to know what is the minimum amount which is required. So moving to next, coagulation power. According to Hardy's rule, greater the valency of the active ion on the flocculating ion, greater will be its coagulating power. Therefore the ions carrying the charge opposite to that of the solution particles are effective in causing the coagulation of the solution. Even the coagulating power of an electrolyte is directly proportional to the valency of the active ions which cause coagulation, which are here electrolyte ions of the electrolyte, which are active ions. So the effective ion of the electrolyte help in bringing about coagulation are those which carry charge opposite to that of the colloidal particles. These ions are called coagulating ions. So greater is the valency of the coagulating or the coagulating ion, greater is the power to bring about the coagulation. So this is what happens. We have impurities, we add coagulant. The more is the coagulant, easily the impurities will remove and the precipitate traps and settle at the down, and we get a purified solution. So we can say, what is coagulation? The sum up of all what we discussed. Yet all the colloidal particle in a solution we know that have a same charge. That is the reason that they do not get settled down. So the coagulation to take place, we have to add electrolyte. So the fluctuating value, the coagulating power of an electrolyte is expressed in terms of its coagulating or coagulation value, which may be defined as the minimum concentration of an electrolyte required to cause the coagulation of a solution. A smaller coagulation value indicates the greater coagulation power of the electrolyte. So we can say coagulation power is inversely proportional to flocculation value. Greater is the flocculation value, lesser will be the coagulating power. Lesser will be the coagulating value or flocculating value, greater will be the coagulation power. And this coagulation can be achieved by electrophoresis by mixing two opposite solutions. So this is the example for a negative sol and for a positive sol. Negative sol get coagulated by these and the power will decrease as we move from aluminium to sodium. And for a positive solutions, the power will decrease as we move from compound of iron to the chlorine. This is what we discussed. So if the impurities are positive, so we need a negative electrolyte, and if the impurities are negative, we need a positive electrolyte. This is what happens when we use these type of a solution electrolytes, and we can check the powers by using one by one. So how the coagulation of electrolyte or a lyophobic sol can be carried out by using the electrophoresis we discussed in this lecture by mixing of opposite sol. For example, we mix positive and negative colloidal solution. Then what will happen? Positive and negative charge get coagulated. They cancel out the charge and we get a coagulation. Similarly, we can boil. If we boil a solution, then with collision of the molecule dispersion medium, they reduce their charges and precipitation take place. Further addition of electrolyte, we discuss coagulation can take place by neutralizing the charge, and we discuss Hardy's rule. So these are the methods by which coagulation can take place. Now our next topic is protection of colloids. How the colloids can be protected. For example, we have a colloid, and a protective colloid is a lyophilic colloid that when present in a small quantity keeps the lyophobic colloid from precipitating under the coagulation action of electrolyte. So protection of colloid is basically a thing which we add to prevent the coagulation or to prevent the precipitation. For example, for a lyophobic colloids, we add lyophilic colloids which protect them to get coagulate. They do not make the colloid possible to react with the electrolyte and prevent the coagulation. So the protective colloid is basically the addition of a large amount of hydrophilic or lyophilic stabilize the system, which stabilize your hydrophobic or a lyophobic part and helps to protect the colloid. So stability of colloids, we can say stable colloids get sediment and flocculation take place, and we have a phase separation. We can separate this by this. Similarly, for flocculation, after flocculation we have a coagulation, and after that sedimentation we get this. So this is what the stability of colloid and how we can separate the phase, dispersed phase or dispersion medium. So this is what we discussed, and this protective or protection is also known as your gold number. This we discussed. Then we can protect this lyophobic colloid by lyophilic particles from separating out or precipitating out in the presence of electrolyte. So this is our last topic, that is gold number. It is basically the number of a milligram of a hydrophilic colloid that will be prevent the precipitation of 10 ml of a gold solution on the addition of 1 ml of 10% sodium chloride. So we can say it prevents the gold particles to get precipitate. So gold number is a term used in colloidal chemistry. It is defined as the minimum amount of protective colloid in milligram which prevents a color change from red to violet of a 10 ml gold sol by addition of 1 ml of 10% NaCl solution. So if we add this 10% NaCl solution in a gold, then this color change will not seen, but these all four containers will show the color of a gold particles. This is gold is red in color, and this is purple, this is blue, and this is golden, which you see in your normal day-to-day life, which is done by addition of 10% NaCl solution of 1 ml in 10 ml of gold, which prevent the color change for a gold particle. So this is all what we studied in this lecture. Hope you guys understand this. Thank you.